Hello, welcome AP Calculus. I so miss you all. I am excited to start distance learning. I am going to be doing problem 1 from your packet for this topic, for the graphs topic. I am hoping that you all will kind of bear with me here and go through problem 1 together with me so that you're writing what I'm writing, and I'm hoping that that gives you kind of more confidence to go on and do problems 2 through 6. But of course, you can always check scoring guidelines as you're going if you need some help on those as well. All right, so let's read problem 1 together. This is coming from the 2013 test, question 4. So no calculator. It says the figure above, or in this case to the right, shows the graph of f prime, the derivative of a twice differentiable function f on the closed interval 0 to 8. The graph of f prime has horizontal tangent lines at x equals 1, 3, and 5, which we can see there. And the areas of the region between the graph of f prime and the x-axis are labeled in the figure. The function f is defined for all real numbers and satisfies f of 8 equals 4. Okay? All right, so I think we've got a good picture of what's going on here. We're given the graph of f prime, so I'm guessing they're going to ask me a few questions about f. And also, very kind of them, they gave me the areas for each of these pieces. So like this has an area of 2, this piece has an area of 6, this piece has an area of 3, although an integral value of -3, correct? And then this piece here has an area of 7, okay? So that is going to be helpful. All right, let's read part A. It says, find all values of x on the open interval 0 to 8 for which the function f has a local, also known as a relative, minimum. Justify your answer. All right, what do we remember about the Peterson diagram? I'm going to draw it on the top here. I've got concave up, concave down, increasing, decreasing, and positive, negative. Okay, so it says that we want f to have a local min. In other words, I want f to look like that, right? I want it to go from decrease to increase, okay? Well, if I want f to go from decreasing to increasing, that means f prime, remember each time you move to the right, you're taking a derivative, so that means f prime must be changing from negative to positive. So if f is changing from decrease to increase, f prime should be changing from negative to positive. All right, what do we think? Does that ever happen on the given graph? Remember, the given graph is f prime. Yes, f prime changes from negative to positive right here. Remember, below the x-axis to above. So f has a local min at, that looks like x equals 6. Justification, since f prime changes from negative to positive there. Yeah, and that is it. Alrighty, I'm actually going to do part B last. Let's move on to part C and D, and I've copied our diagram here for us as well. So part C says, on what open intervals contained in 0 to 8 is the graph of f both concave down and increasing? Explain your reasoning. All right, very similar to what we just did, except we've got 2 parts instead of 1 in a way, okay? So remember, they're asking us about f, but they did not give us the graph of f. They gave us the graph of f prime, okay? So let's come back to our diagram. If f is going to be concave down, that means I will put f here. Then the given graph, the derivative, if I move over 1 slot and stay on the negative side, the derivative, f prime, should be decreasing, okay? Now, if I want f to also be increasing, so I'm going to put f here, then that means its derivative should be here in this slot, positive, right? So let's see, where do we have f primes? We have f primes here at decreasing, and here at positive. So I need f prime to be both decreasing and positive. And remember, for a graph to be positive, that means it's above the x-axis. So I'm liking this piece here, decreasing but positive, and also this piece here, again, decreasing but positive. Okay, so f is concave down and increasing on the intervals 0 to 1 and 3 to 4. What's the justification here? Well, since f prime is both decreasing and positive there. Okay? All right, let's go to part D. It says the function g, so here's a new function, is defined by f of x quantity cubed. If f of 3 is negative 5/2, find the slope of the line tangent to the graph of g at x equals 3. We've seen that a lot, right? What does the slope of the tangent line, what is that? That's just the derivative, right? So what they're really asking is, what is g prime of 3? Right? And if you go ahead and write the whole equation, that's fine, but they'd really just care about the derivative here. Okay, so, well, let's first find g prime of x. So coming back here, any special rules? We need chain rule, right? So derive the outer, holding the inner, power rule there, right? Fly the 3 and then drop the power by 1. Then times the derivative of the baby. And derivative of the inside will just be f prime of x, okay? So if I apply this to x equals 3, I get 3 times f of 3 squared times f prime of 3. And let's see, I think they gave me f of 3 right here, correct? So f of 3 was negative 5/2. I want to square that. How could I find f prime of 3? Right, so the given graph was f prime. So if I come up here and look at the graph, f prime of 3, in other words, the y value of this graph when x is 3 is 4. Okay, and I'm going to encourage you to leave your answer like that, okay? Let's not simplify more than we have to, okay? Great, so that's A, C, and D. Let us go back to part B now, okay? All right, so part B says determine the absolute min value of f on the closed interval 0 to 8. Justify your answer. All right, let's go back. What did part A ask us? Do you remember? It asked for the local min, the relative min, right? What is different about this? It's asking us for the absolute min of the same function of f, okay? So not of this graph. This is f prime. Remember that. They're never going to say, hey, find the lowest point on this graph. That's an algebra 2 question, not a calculus question. Okay, so they're asking us for the absolute min value of a graph we don't know. All right, so for absolute mins, do we remember the strategy there? So for absolute extrema, we make a table, right? So this is extreme value theorem, and we are guaranteed absolute mins and maxes if we're looking at a continuous function on a closed interval, where here's a continuous function, here's our closed interval, and our function's certainly continuous because it's differentiable, right? The derivative exists, so it's certainly continuous. All right, so I'm going to make a table. Remember, here is x, and this is f of x, what I'm trying to find the min value of. And do you remember what are our candidates? What goes on the left-hand side? Yep, your endpoint, so 0 and 8 in this case. And then any relative mins. Well, how nice, we found the relative. There's only one relative min in part A, that was 6. Now, if you look at scoring guidelines, a couple things I want to point out to you. Number one, they will not always use a table. Sometimes they'll just kind of leave that organizational piece off a bit, but they are still finding all these values, okay? But I really like the table format to keep it organized for you. Another thing, they may actually go ahead and find f of x at every single critical point. okay, which is fine. It's just doing more work than you actually need. So I like to just say, okay, if I'm just finding absolute min, let me narrow it down to looking at just my endpoints and my relative min, okay? If I were looking for absolute max, I would do my endpoints and where my relative max occurred. But on just FYI, on scoring guidelines, you might see that they analyze more x values than they do. But if you go and look at the point distribution, you'll see that they just give points for the endpoints and the relative, in this case, min. Okay. All right. So what do we know? I copied this f of 8 equals 4 from the stem of the problem. So we do know that. Hurrah. But what about the other two? What are the other two? We need to do a little bit of work for the other two. Okay, any idea what we will be doing? Well, notice that they gave you one function value and asked you to find another one, right? So that is our friend FTC, okay? What is FTC again? Here is what FTC says. Remember that if you've got a definite integral from a to b of f prime of x, that one way to evaluate that definite integral is to antiderive and then evaluate at b and a, right? So an antiderivative of f prime is f. I want to evaluate that at b and a. So this is f of b minus f of a. And if I rearrange that and that a bit, in other words, if I solve for f of b, I get that f of b equals f of a plus the integral from a to b of f prime of x dx, right? There's our good old friend FTC, fundamental theorem of calculus. Okay. All right, so let's do a little bit of work here. Let's take a look at, we want to find f of 0, right? So for this first one, I've got f of 8. Okay, so remember that you want a typically to be your smaller value. That way you don't have to worry about improper integrals. So a, my smaller x value is 0. B is going to be my larger x value, 8. Okay, so now let's go ahead and plug that into this. Okay, all right, so I've got f of 8 equals f of 0 plus the integral from 0 to 8 of f prime of x dx. All right, f of 8 was given. Remember, that was 4. F of 0 is what I'm trying to find. That's what I want to plug in right there, right? That's what I'm trying to get to. And how can I find the definite integral from 0 to 8 of f prime? Well, I have the graph of f prime, and how kind, I have all the areas, right? So if I want to go from 0 to 8, I want to take this area plus this area minus this area plus this area, right? All right, so that is going to be 2 plus 6. They gave me all these, minus 3 plus 7. Again, I'm subtracting that area that's below the x-axis. So we have got 12 here, correct? So 8 minus 3 is 5 plus 7 is 12. So if I solve this for f of 0, I get that f of 0 is 4 minus 12, so negative 8. Okay, so now I can go and plug negative 8 here. All right, let's do the same thing for f of 6. Okay, so again, a is now 6, b is 8. Plugging in from there, I got f of 8 is equal to f of 6 plus the integral from 6 to 8 of f prime of x dx. Again, f of 8 was given, that was 4. F of 6 is what I'm looking for in this case. And then the integral from 6 to 8 is just going to be this area here. So that was given to be 7. So solving for f of 6, I have 4 minus 7, which will be -3. Okay, great. And now we wanted absolute min, remember? So what is my lowest y value? It's -8. So final statement, this is how I would like for you to write it. Absolute min value of -8 occurs at x equals 0. Okay, I'd like for you to state both pieces, because sometimes they ask for where it occurs, sometimes they ask for what it is, and if you get in that habit, you won't accidentally say the wrong thing. Okay? All right, so that is 2013 AB4. What I would like for you to do next is finish your packet. So the idea is that you kind of have 2 days on that packet, so hopefully you already wrote the answers to the example down. Make sure you kind of go over that again before you start jumping into these. We just did problem 1 together, so I want you to take, assuming that you're doing this on Monday, if not before, I want you to take 2 days to finish problems 2 through 6. Make sure that you are checking with the scoring guidelines from College Board. Okay, the link is at the bottom of the packet. And the way I'm going to grade this is that you just submit a picture of yourself working these on Canvas. And I will have a place for you to submit that on Canvas, so keep an eye out for that. Once you've spent a couple days on this packet, I'd like for you to go try the graphs review in AP Classroom. It should be open for you, okay? You are just getting points for attempting each part and then looking at your answer, and that should be open. That should all be open for you. So this is just a completion grade, the stuff on AP Classroom, okay? And then I want to see you at 1:30 on Thursday, and we're going to do some of these together, kind of like we did the cold FRQs in class. So I'm going to give them to you. I'm going to give you 10 to 15 minutes to try one on your own, and then we're going to talk through the scoring guidelines, and you can ask any questions you have about scoring guidelines and such then, okay? All right, I miss you all very, very much, but I'm excited to kind of keep learning with you all here and keep going. Please, please don't hesitate to reach out to me either via Remind or email or Canvas if you have any questions, and I will do my best to answer them as quickly as possible. All right, lots of love to you all. I will talk to you all soon. Bye.